Hi guys, we were talking about applications of trigonometry in our daily lives. This was part of chapter 9 in the NCERT book. Now let's look at another example which would help us understand these applications. So here's the question. It says a flagpole which is 10 feet tall stands at the top of a building. The angles of elevation of the top and the bottom of the pole as observed from a point on the ground are 60 degrees and 45 degrees respectively. Find the height of the building. So let's first draw the figure. So there's a building and let's say this is the ground and there's a pole on the top of the building. So let's say this is the flagpole. So length of this pole is 10 feet. That's given to us. So this length is 10 feet. We have to find out what would be the length of the building. Let's suppose this length is x. We are also given that the angles of elevation from a point on the ground, let's assume that this point here, so the angles of elevation of the bottom of the pole, that is this point, and the top of the pole, that is this point, are 45 degrees and 60 degrees. Let me just draw the line of sight. So if this is the line of sight for the bottom of the pole, then this angle is 45 degrees. And if this is the line of sight for the top of the pole, then this bigger angle, this one, would be 60 degrees. Now we have to find out the height of this building till here. So we've already assumed that the height of the building is x. Let's see how do we find out this x. First of all, let us assume that this point is point A, the bottom of the building is point B, this point is point C, and the point here is point D. We are just naming these points so that it's easier for us to refer to these. So here we see that angle B is equal to 90 degrees. That's the right angle here. So there are two right angle triangles here, ABC and ABD. We know the length of the pole, that is CD, is equal to 10 feet. We have assumed that the length of the building BC is equal to x feet. We can also assume that AB is, let's say, A feet. A is some number. This point, this length is A. So the point A is A units or A feet away from the base of the building, that is point B. So let's first consider triangle ABC. Here, if we consider angle A, which is equal to 45 degrees, we can see that tan of A is equal to tan of 45 degrees, which is equal to the opposite side, that is BC, by the adjacent side, and the adjacent side is AB. So this implies, remember tan 45 is 1, yes, and BC we have assumed as x and AB we have assumed as A. So from here we can say x is equal to A. Now let's look at triangle ABD. In triangle ABD, angle A is 60 degrees and not 45 degrees. Now this is the bigger angle that we are considering for triangle ABD. In triangle ABD, we can write tan of angle A is equal to tan of 60 degrees, that is equal to BD by AB. Now if we look carefully here, BD is nothing but BC plus CD and over AB. So from this we can write tan of 60 degrees is root 3 is equal to BC we had assumed as X, CD is given as 10 feet and AB we had assumed to be equal to A. So from this we have root 3A is equal to X plus 10. Let this be equation 2. Now we have two equations, X is equal to A, and this equation root 3A is equal to X plus 10. Here we have two variables and two equations. So we can easily find out the values of X and A. Let's just solve equations 1 and 2. So if I replace A by X in equation 2, I would have root 3 X is equal to X plus 10. This follows from equation 2. This would imply root 3 minus 1 times X is equal to 10. And we can assume that root 3 is equal to 1.732. So here we would have 0.732 X is equal to 10. This would further imply X is equal to 10 by 0.732, which is equal to 13.66 feet. So now we know X, that is the height of the building, is nothing but 13.66 feet. And we also know that A was also equal to X, and hence this distance also is 13.66 feet.